Hello, my name is Greg, and I am a tutor with Chegg Tutors, and today we will be covering the topic of acceleration. So the formal definition of acceleration is the rate of change of velocity of an object. So in SI units, that is acceleration is meters per second squared. We'll see how that plays in when I do an example later. So one note about acceleration is that it is a vector, meaning it has direction and magnitude. So let's say we have an acceleration of 5 meters per second squared. We need to add a direction to that, so it would be 5 meters per second squared to the right. So again, it's a vector, has direction and magnitude. So the equation for acceleration is equal to the change in velocity over the change in time. So again, it's the rate the rate of change in velocity. And here we have delta v, and again that is the change in velocity. I want you to note that change in velocity can either mean slowing down or speeding up. I think people kind of have a misconception of acceleration, thinking that it only applies when, let's say, if you're driving in a car and you step on the gas, you're accelerating. While that is true, people don't really think that you're accelerating when you're also braking. So acceleration it works and it applies when you're speeding up or you're slowing down. It's just then that's the whole that's where the direction comes in. That's why it's a vector, because you can either be speeding up in one direction or slowing down in another. Going on, here we have an example of a car. So we have at time 0 seconds, we have a car going 20 meters per second. And at the final time of 5 seconds, so 5 seconds later, it is traveling at 30 meters per second. And we want to find what the acceleration is. This is a simple problem. All you have to do is just plug it into the equation. We have acceleration is equal to change in velocity over change in time. So that's the final velocity minus initial velocity divided by final time minus initial time. And that equals 30, final velocity 30 meters per second minus the initial 20 meters per second divided by the final time 5 seconds minus 0 seconds. If you just calculate that out, you get 10 over 5, or 2 meters per second squared. And because this is a positive 2 meters per second squared, that implies the direction. If we set our positive as the positive x-axis going to the right, then that means that this 2 meters per second is positive, means that it's accelerating to the right as well. And you can see that it's accelerating to the right because it's speeding up. Now let's do another, I'll continue on with acceleration where it comes from. So acceleration is the net result of forces acting on an object. So to get acceleration, you essentially need some external force acting on the object. In the case of this car, what's causing it to accelerate would be, let's say, the engine pushing on the wheels, on the axles, and that's the external force acting on it. So we have equation for force, which is Newton's second law. It's equal to force is equal to mass times acceleration. And I'm sure you know that. If not, then maybe we can review a little bit. But we are going to do an example of how F equals ma works. So here we have a box. Let's say on a frictionless surface, so we don't have to worry about friction. So we have a box of a mass 10 kilograms and a force of 20 newtons acting on it to the right. We want to find what the acceleration of this box is. And again, now we can just use the simple Newton's second law, F equals ma. So we have acceleration. If we just rewrite this equation, we get acceleration is equal to F divided by m. And this equals the 20 newtons divided by 10 kilograms. And this acceleration is equal, again, to 2 meters per second squared. And since it's positive, it's acting to the right, since we set our positive x-axis to the right. So that really is what acceleration is all about. I just covered the basics, but I hope you get a good understanding of what it's all about. If you have any questions, the link to my profile is in the description. Please feel free to message me. and I will try to answer your questions as best as I can. And that is it. Thank you.